In 2010, John Kindervag coined zero trust with a simple rule: never trust, always verify. This week, ask yourself, does your network still grant implicit trust behind a firewall? In nearly every zero trust assessment I perform, I find AI agents with contributor roles on entire subscriptions. That's the opposite of least privilege. Fix it today. Audit your managed identities for overprivileged roles before enabling autonomous AI. Zero trust isn't something you buy from a vendor. It's a security mindset. Never assume anything inside the network is safe. Every single access request, from a user, a device, or an AI agent, must prove its identity and authorization every time. For years, security was a hard shell. Firewall outside, implicit trust inside, like a music festival wristband. That model fails when your apps and AI agents live in the cloud, outside the perimeter. Zero trust flips the script. No wristbands. Every request, human or AI agent, must pass identity, device, and sensitivity checks before touching any resource. Every access, every time. This isn't a new buzzword. 2005, Jericho Forum Deperimeterization. 2010, John Kindervag coins zero trust. Then NIST issued ZT architecture guidance. 2 decades of evolution, one rule: trust nothing, verify everything. Stolen credentials are a top attack vector. AI agents using long-lived API keys multiply the blast radius. Zero trust eliminates those keys. It uses managed identities and just-in-time tokens. Imagine a cloud resource with an overly permissive IAM role. An attacker gains access through a misconfiguration and exfiltrates sensitive data because the role had far more permissions than needed. One overprivileged role turned a single vulnerability into a catastrophe. A sophisticated attacker used a password spray on a legacy test account without MFA, gaining a foothold inside the environment. After the password spray compromise, overpermissioned OAuth applications gave the attacker keys to production systems. Zero Trust's least privilege limits every identity to the absolute minimum, blocking that pivot. Attackers forged authentication tokens from a stolen signing key, accessing sensitive systems without triggering alerts. Zero Trust. Continuous verification detects such anomalies. Verification never ends. A real-time Custo alert fires when an AI agent exceeds 100 search queries in 5 minutes, a sign of credential misuse. In many breaches, initial compromise is survivable. Implicit trust after auth turns them into catastrophes. Zero Trust replaces trust with explicit verification, least privilege, and segmentation, shrinking impact from mega incident to minor alert. An AI agent with broad permissions fell victim to prompt injection, allowing an attacker to spin up crypto mining VMs and exfiltrate data, all from a trusted identity. Identity without least privilege is just a nicer credential. Imagine an AI agent with overly broad permissions. A simple prompt injection could let an attacker spin up crypto mining VMs and exfiltrate data, all from a trusted identity. Identity without least privilege is just a nicer credential. Layered zero trust controls would have stopped the overprivileged agent. Scoped roles block the VM creation. Network isolation prevents data exfiltration. Deny policies keep the storage firewall locked, and the anomaly alert notifies the SOC before the mining bill accrues. The managed identity deleted the API key, but the contributor role handed the attacker the entire subscription. Zero Trust demands fine-grained RBAC. For the AI agent, that's Cognitive Services OpenAI User and Search Index Data Reader, nothing more. Picture a bouncer who checks ID every time you approach any door. No wristband, no "I already saw you." That's zero trust. No implicit trust. In practice, that means implementing conditional access policies that require MFA every time a user accesses a new resource. No cached trust. Old models trusted a device once inside the firewall. Zero Trust never trusts, always verifies. Even a trusted laptop can be denied access in real time. Zero Trust re-verifies every request with 5 signals: user identity, Microsoft Entra ID, device compliance, IP location, application context, and data sensitivity label. Every request must pass all checks. Zero Trust re-verifies every request with 5 signals: user identity, Entra ID, device compliance, IP location, application context, and data sensitivity label. Every request must pass all checks. When the agent calls Azure OpenAI, the identity uses a single RBAC role: Cognitive Services OpenAI User. No subscription-wide contributor. Same pattern for AI Search and Key Vault. If the container gets compromised, it can't reach anything else. One broad role, like contributor, gives an AI agent full access to the entire resource group. Zero Trust carves that into fine-grained roles, each granting only the specific permissions needed for one task. If a credential leaks, the blast radius is contained. Breach is inevitable, so we build as if it already happened. Segmentation stops the attacker from hopping to other systems, encryption locks down data, and centralized monitoring cuts the detection time from days to minutes. 4 Zero Trust controls in a continuous monitoring loop: network segmentation, encryption at rest, centralized logging, and anomaly detection. If unusual activity spikes, it triggers alerts, minimizing potential damage. Zero Trust doesn't throw out network controls. It just stops treating them as the only trust source. An on-prem laptop still needs identity checks. A coffee shop device that meets your policies can still get in. A managed identity eliminates secret rotation, but without least privilege, you just traded a key for a token with the same blast radius. The rule: one system-assigned identity per workload, scoped to exactly 3 data plane roles. A Docker Compose with hard-coded keys landed on GitHub. Within hours, a crypto miner could rack up charges. Zero Trust prevents this. No keys in repo, locked-down identity, no internet, and early detection. Banks deploying AI trade settlement use ephemeral RBAC, permissions granted per batch, then revoked. The agent is air-gapped, and all auth events flow to a SIEM. Zero Trust delivers audit-proof access. This is the blueprint: a container app with system-assigned managed identity, private endpoints inside a VNet, no public IPs. Every auth event streams into log analytics. Next, we'll assemble the Zero Trust Foundation's key components. Managed identities eliminate stored credentials. Private endpoints isolate network traffic to the Azure backbone. Key Vault secures secrets with RBAC and logging. Together, they lock down the foundation so every service-to-service call is authenticated and inspected. Monitoring flows through log analytics and app insights. Azure policy blocks public access. Each layer enforces never trust, always verify. The agent's managed identity requests a token from Entra ID. The short-lived JWT authenticates to Azure OpenAI and AI Search. No API keys in code. Credential rotation is eliminated. When the agent calls OpenAI Azure.com, private DNS resolves it to a private IP, not a public one. The connection goes through a private endpoint to the service, and all traffic stays on the Azure backbone. No data ever leaves Microsoft's network. Only 3 tightly scoped roles: Cognitive Services OpenAI User, Search Index Data Reader, and Storage Blob Data Reader, and nothing else. Even if the identity is stolen, the blast radius is nearly 0 because no role grants network-level access. A role assignments resource in container app.bicep uses the agent's principal ID and built-in roles like Key Vault Secrets User. Repeat for OpenAI and Search. No manual clicking, no forgotten permissions. The policy.bicep file defines 2 custom policies that deny public access for Cognitive Services and Key Vault. Assigned with enforcement mode default, any attempt to create an unprotected resource fails instantly, hardening the resource group and inheriting Zero Trust across future deployments. With the Azure policy assignments, the entire resource group becomes an enforced Zero Trust zone. If a pipeline accidentally attempts a public endpoint, the policy blocks provisioning before it starts. Governance baked into the deployment code. No manual review. Every authentication attempt and API call is captured. The agent's telemetry flows to application insights into the same log analytics workspace, while diagnostic settings on OpenAI search and Key Vault stream audit logs, nothing unseen. A scheduled Custo query monitors search queries. If unusual activity is detected, an Azure Monitor alert fires, notifying the security team. Detection times drop dramatically, containing the blast radius. This Custo query runs against log analytics. When an identity fires an unusual number of search queries in a short time, it flags the anomaly. Detection drops from hours to minutes, containing the blast radius. 2 steps turn the Custo query into a live alert. First, create an action group that emails your security team. Then, deploy the scheduled query rule, evaluating every 5 minutes. If the threshold is breached, the alert fires instantly. Imagine a leaked API key going undetected for hours, racking up charges. With this architecture, an anomalous search rate triggers an alert quickly, containing the damage before it escalates. Continuous verification never stops. One command. That's all it takes. In just a few minutes, Azure provisions every component: private endpoints, managed identity, Key Vault, Azure OpenAI, AI search, and the enforcement policies, locked down under a single zero-trust blueprint. No pre-provisioned resources required, just an Azure subscription with contributor access, the Azure CLI and Bicep tooling, and optionally, Docker. Don't have Docker? Grab the ready-made agent image from the GitHub container registry and skip the build entirely. Agent.py reads environment variables, authenticates with default Azure credential, fetches the OpenAI endpoint from Key Vault, runs a chat completion, and queries the search index, 0 hard-coded secrets. The build pipeline consists of packaging your agent code, building a slim container image, and pushing it to your private container registry, all automated with a single command. If you don't have Docker or prefer to skip the local build, simply pass the pre-built image as your agent image parameter. The container still runs with the same managed identity and network isolation. Zero trust is never sacrificed. The network module creates a fully private virtual network with dedicated subnets for container apps and private endpoints. The container environment only uses private IPs, no public endpoints anywhere. 3 private DNS zones ensure that even name resolution stays locked inside the VNet. When the agent resolves the OpenAI, search, or Key Vault endpoint, it always gets a private IP address, never the public internet, never a chance for DNS exfiltration. Monitoring.bicep creates a log analytics workspace and an application insights instance. It outputs workspace ID and connection string, so every module streams diagnostics. No resource stays in the dark. KeyVault.bicep enforces zero trust at the credential layer. RBAC authorization, public access denied, private endpoint created, and all audit event logs streamed to the workspace. No shared keys, no public exposure. OpenAI.bicep and search. Bicep followed the same zero-trust blueprint. No public network access, private endpoints, and diagnostic streaming request, response and audit logs to log analytics. Every call, including query counts, becomes an auditable event. ContainerApp.bicep creates a container app with system-assigned identity, no ingress, and envvars from Key Vault. It then creates 3 RBAC role assignments, each using a deterministic guide for idempotent redeployment. These 3 role IDs grant only needed permissions. The overprivileged retrieval agent had contributor and created VMs. This identity can't write, delete, or create. Least privilege prevents a contained incident from becoming a subscription takeover. Policy.bicep enforces guardrails. 2 custom definitions deny public access on cognitive services and Key Vault. Enforcement mode. Default blocks any deployment without public network access. Disabled. No exceptions, no forgetting. Main.bicep orchestrates in order, network and monitoring first, then services needing subnets and workspace IDs, then the container app, and finally policies. One AZ deployment group create materializes the entire zero trust foundation. Traditional setup. A leaked API key exposes you to significant fraud risk. With zero trust, no static key, just managed identity. Attack surface shrinks from wide open to private. If compromised, damage contained in minutes, not days. Running this lab for a day will incur costs, primarily from Azure OpenAI. The official guidance? Deploy, validate, delete. Don't leave it running. The learning is in the deployment and logs. After deployment, stream agent logs. You'll see identity-based call to OpenAI and search fetch. Then trigger a denied operation and check app traces for authorization failed to see which RBAC check blocked it. Prove zero trust denies off-scope actions. Trigger a call to list all search indexes. RBAC blocks it. The result: an immediate authorization failed error in log analytics. Query: app traces to confirm the deny in real time. Never store private keys in code or repos. The PowerShell demo here uses a local certificate only to show token flow. In production, rely on system-assigned managed identities or secure the key in Key Vault with sign operations. Verify explicitly, least privilege, assume breach. These three principles are platform agnostic. Azure uses managed identities. AWS uses IAM roles with condition keys. GCP scopes service accounts. On-prem micro-segmentation forces verification every step. Zero trust is career currency. Microsoft's security certs tested. AZ500 requires implementing secure access via identity. SC100 designs AZT strategy. SC200 demands continuous monitoring. Add these to your study plan. Don't guess. NIST's Zero Trust guidance is free. Forrester's reports explain strategy. Microsoft's deployment guide maps ZST to Azure, and the Azure Architecture Center has reference patterns. Bookmark these. Zero Trust boils down to three non-negotiable principles. Memorize them. Every architecture decision flows from here. Verify explicitly, enforce least privilege, and design as if already breached. These three pillars are what separate a hardened system from a headline. If every component is designed as compromised, credential theft exposes only a tiny surface. One overprivileged credential caused the Capital One breach. Minimize blast radius from day one. Zero trust. Never trust, always verify, authenticate, and authorize every request. Action. Spend 15 minutes auditing your Azure conditional access policies to strip implicit trust assumptions. Part 3. AI Agent Anatomy next. Concrete next step. Download NIST's Zero Trust Guidance, linked below. Spend 30 minutes mapping one component, like identity or network, against its principles. Know your gaps before attackers do. Part 3 dissects AI Agent Anatomy. But first, lock in today's lesson. Download NIST's Zero Trust Guidance and map your environment's logical components this week. Subscribe to catch the next deep dive.